Okay, so in this lesson, we're going to go over the project structure that we're going to use for the rest of this semester. We'll go over the build system, the testing system, and how to work with this system using VS Code. We're going to do it while we implement a super complicated Hello World, which would be fun. So let's get to the code and go over this. Okay, this is assuming that you've already accepted the assignment and have cloned it down using VS Code. So if you're watching this and you haven't cloned it yet, make sure and clone it down. And it is described here in this links, cloning and submitting. So let's go over this. Let's go over this at a high level. So at a high level, this is just warm up. In fact, I'm going to solve this entire lab for you. You can watch me and follow along. The main part of this lab is to get you to get you familiar with the project as it and its the project and its build system. So in this class, we're going to actually use a build system, a professional build system. We're going to use Gradle. So in industry, you don't typically build stuff by evoking the compiler directly from the command line. That becomes extremely unwieldy once projects get to a certain size. What we're going to do is we're going to use Gradle, and we're going to do it like you do in industry. So first off, here's Hello World Boring Edition, right? So this is something that you probably wrote in 121, and it's pretty simple, right? Do a class hello, compile it, and then run it, and it outputs whatever you have in your print line. So what we want to do is, that's boring, right? We want to do Hello World Enterprise Edition. Enterprise Edition is this is tongue in cheek, obviously. So an enterprise grade Hello World needs to be a little bit more robust. So the build system, I give you some options here. Well, not options. I give you some. I kind of lay out some of the biggies in Java development. We have Ant, Maven, and Gradle. We're going to select Gradle simply because it's the newest. It's the one that was officially adopted by Google for the Android build system, so it's a double dip. Not only do you learn it for here, but now if you do mobile development, you will also know what they're doing. And generally speaking, it's a pretty good system. I mean, I've had pretty good luck with it overall. For testing, we're going to use a framework called TestNG. TestNG is allows us to quickly run unit tests on our code. There's a lot of different testing frameworks out there. There's TestNG, there is JUnit. At this point, they're all pretty similar, especially when we're just doing simple things like what we're doing here in 221. You don't really need the really complicated features until you start having really large projects. We're mainly going to be using TestNG assert. So if you click here, you can see that the assert class has a whole bunch of assert methods. Don't worry, I know there's a lot of them, but most of these, you're going to be using a very, very small handful of these. And for the most part, these are all just method overrides, which you'll learn about. So this looks intimidating, but in reality, it's pretty doable. All right, so let's first walk through the setup, and then we're going to go and do the tasks, and we're going to do them together. So the first thing is the app is the main code is under app, source, main, and then you'll see where you have all of the Java files, and then a folder main Java lesson. The testing code is a mirror test Java lesson, and it has your testing class. Now you may wonder why you have such a deep directory hierarchy. It seems kind of silly. It's required by Java. It's just the way Java is. It was part of the Java design. It actually does make a lot of sense in production, because in production, having this rigid structure makes it easy to find stuff. And believe it or not, finding things in a large project can be hard. So this may look weird, but it's the way all Java projects are. And some of it is actually enforced by the compiler. So if you go and move all these files to say the source and try to compile, the compiler won't even let you do it because we're using packages. The compiler will just fail. So you have to do it. It's enforced by the language. Okay, so that's our source. We have our main stuff right there. There are our implementation, and then we have our testing code. So let's go ahead and close that up. We have a build. We just ignore this. See how it's kind of grayed out. You never want to commit this to your repository. You kind of want to ignore this. This is just artifacts. This is what's called build artifacts. And there's a lot of stuff that is generated when you build. And honestly, just ignore it because it's not important. It's don't delete it because the build system needs it, but you shouldn't be going down into the build directory. Then you got bin, which again is just more. It allows the build. It's for the build system. So at this point, don't worry about bin. Don't worry about build. Gradle is a hidden file. It's .gradle. It's more stuff for the build system, and .vs code is for the editor. So this is where any settings or configurations that you might have for your editor. So if you could customize stuff, it'll show up here. Okay, so the build.gradle is how it actually is what defines the build system. Gradle is largely a plugin driven system, and again, there's no quizzes or tests or stuff on Gradle. It's just a high level. It's just the knowledge is for a high level understanding, and just know it exists. Build systems are an incredibly complicated beast that you will get used to over your career, and they change frequently. So we're going to use Maven. Maven is how we get our dependencies. Maven is just it's a plugin that allows us to download stuff automatically because one of our dependencies is the test-ng framework, and we're going to use this framework to do our testing. Our main class is lesson.app. Again, you don't have to worry about this too much. And then use test-ng is required to use the testing. Now, the cool thing about having Gradle and using VS Code is everything should just show up. In fact, you should have a little beaker here. If you click on this is the testing, and everything will automatically discover here as there's nothing here because we haven't written anything. But as we write the tests, it'll pop up right there. Okay, so we've gone over the code. We gone over the Gradle. Okay, build.gradle. Now, the Gradle wrapper, you don't have to worry about this. This is just what enables you to not have to install Gradle. Basically, when you clone this, it'll all be there, and it'll just work out of the box. So, but don't delete it either. It's necessary. All right, so get attributes. This is to help with Windows because on Windows, line files are a little bit are different than everybody else. So just don't change it. It is just to help so those students who are on Windows so their files don't get messed up. Get ignore. This is stuff that we don't want to worry about. We never want to commit or worry about our .class. I know it might seem important, but it doesn't matter. What's important is the Java files. So if we look at here, the Java files are what's important. The class files nobody cares about because you can just rebuild them. You can recompile them. You don't want to save those. And all this other stuff is just artifacts that are generated by Gradle. At this point, you don't need to worry about them. Just know that you don't have to deal with them. Okay, Gradle is how we actually build on Mac and Linux, and Gradle.bat is how we build on Windows. So I will walk you all through that. README obviously is the README. Retrospective is something we're going to fill out after we finish this assignment, and then the settings again is just more Gradle artifacts for Gradle to make Gradle work. Now, the focus of this class is not necessarily build systems. So at this point, all you got to know is how to build and where source code is. And as you start working with Gradle, we will talk about Gradle more in later assignments. So, all right, so let's get started. So let's go back over here to the README. And the cool thing about the README, remember, you can click this little button up the right-hand corner. Instead of having a markdown view, you can get a nice rendered view, which is cool. So we're down here. This is what we just talked about. We just talked about the build system. Okay, we just talked about the testing. That's what we just talked about. And we talked about this directory structure, what it all means. So let's do task 0, get our code to compile. All right, so let's open up our code and get started on that. So the first thing we want to do is open up a terminal. So you can't see it, but on Mac, I'm going to go, there's a menu that says New Terminal. I could also just hit F1 on my keyboard and say terminal, right? Create new terminal. That'd probably be the easiest. And now I'm in the correct directory. So now what I need to do is I need to compile the code. So now to compile the code, right, I use Gradle W on Mac and Gradle.bat on Windows. Okay, and if you're on Linux, use Gradle W. So since I am on Mac, I'm going to type /Gradle W. And you can see that the build was successful, so that's good. Well, there's not much. The build was successful because there's not. It doesn't really do anything again. So we can actually run it. Gradle W run, and you can see that it compiles. Oh, there we go. Build fails. So now we can see where 2 errors. Look at that. So now we can say error, say hello is not abstract, does not overwrite. Okay, so this is good. So we have 2 errors, right? So we need to go and fix that. So let's make this a little bit bigger. There we go. Okay, so let's get started. Okay, so I'm going to go ahead and close the README. I'm going to make this a little bit smaller. All right. So let's open up our source code and we'll go open app.java. You can see, okay, it's empty. Okay, so the nice thing about VS Code is it tells me what's wrong, and I can click on here and it has a little light bulb, and I can say add unimplemented methods. And so that's good. So let's go ahead and save that. And I'm going to do the same thing for say world. I'm going to add unimplemented methods. Now don't worry, we're going to go. This is new from 121, but you will learn about what all implements and interfaces are. That you're going to learn about. This is just a preview of the class. And then we have Talker. So our Talker interface, it's an interface. All it does is define one method that says just say something. And so our say hello world, say world implements Talker, and say hello implements Talker, and then our app, we're going to have the app do something as well. So the first thing we want to do though is now it compiles. Let's go and let's do Gradle run. Okay, and build successful. Or I could also type Gradle build, and right, build successful. Right. Sometimes it might get confusing because if you get previous runs, so you could type clear and type Gradle W build. So now we're building. So that's good. So we actually finished now task. We finished task 0, right? Get your code compile. It compiles. So now let's write the tests. So we want to do test-driven development, meaning that we want to write our tests before we write our code. Okay. So I'm going to go down here to test. I'm going to say hello test and say world test. Okay, so both these tests, say hello test, test the hello class. So I can let's put these next to each other. Say hello class and then say hello test. These two are linked. Say world test. Okay, so first thing, let's do the say hello test, and let's go. The defining test is fairly straightforward. We do @test, and I'll say public void. And then this is cool. You can name the test whatever you want. I'm going to say test say hello, and then I'll say now I need to create an object that I'm testing. So I'll say hello equals new say hello. Okay, and what is say hello supposed to do? Well, say hello is supposed to say something, and in this case, it's supposed to say the hello. It's supposed to return a hello string. So in this case, I could say, now this is where I'm going to write a test. So my expected output is the string hello. So I'll say assert equals, and my actual would be hello dot say something, and my expected will be hello. That's what I expect. All right, and let's do the same thing over at say world. In fact, let's go over here to test say hello world. And I'll do the same thing @test public void say world. Is that what I name it over here? Test say hello. Yeah, I'll say test say world. Yeah. And in fact, not to imply that you don't have to start with tests. You can just do that. There's not any requirements on what the method is called. And then I'll say, I I need to declare a new say world class. World equals new say world. And then I'll say assert equals. Actual will be world dot say something. And expected will be world. Now, what's cool is I don't actually have to even write this yet, right? You're so used to writing main. Who cares? Main's not important. I'm going to go over here and look. I actually now have 2 tests. Look, the tests I wrote. Test say hello, say world. Now, I probably want to like make these the same because then it looks nice. I'm just going to do this. There we go. See, now it's say hello, say world. And now what I can do is I can go up here and I can hit this little button. I can say run, and it runs the tests. And it should fail. Look, it fails. That's good. See? Right? Expected hello, but found null. Right? But that makes sense because we haven't completed. So this is our tests are finished. So now let's go over to say hello. Let's finish this. Okay. We go to our class and we'll say return hello. Oops. Hello. Okay. And then let's this is the say hello. So let's go and rerun this test. You can see, look, now it passes. All right, let's do lowercase. It should fail because I'm looking for uppercase. Yep, failed, right? Look at that. That's cool. See? Hello. Okay, it passes. And now I want to go over to say world. Oops, say world. And I want to do the same thing. And I want to say return world. And I will run that. And look at that. All my tests pass. That's cool. So now that's it. Like say hello is good. Say world is good. I have a test for both of them, which is awesome. So now let's go write a command line application to exercise it. So now what we're going to do is we're going to say talker. Talk equals new talker. And this is going to be an array. And I want to now do, oops. Make sure that's an array. And now I want to say talk index 0 is going to be a new new say hello. And talk sub 1 is going to be new say world. And now I can iterate through them. So for talk t in talk, don't worry, everything is going to be explained in the future. This is all new, and we'll go over this syntax in future classes. This is just a preview. And I'll say system.out.println, and I'll say t.say something. And now I can run this one of two ways. I can hit run right here, but let's go ahead and do it. Let's go build. Okay, so I'll show you. Let's go ahead and do run. And you can see right there, look at that. Hello world. I can also just hit run right here. And hello world. So I don't like this though, right? So let's do print. Right, and I'll do plus, right, and then at the end I'll say system.out.println. Okay, so let's go ahead and just run that again. And look at that, hello world. I like that. I like the way that works, and I can also do it right here. Gradle W, again, it's Gradle W.bat if you're on Windows. Run. Okay, that's cool. So now we are done, right? This is it. So now what we have to do, the cool thing, let's review what we did, is we wrote 2 tests that tested our say hello, our say world. We don't implement interface because interface you don't implement. That's the whole purpose of interface, is to define interfaces between classes. We wrote a main that prints out hello world in a super complex enterprise fashion. And that should be good to go. So let's go back to the README. We got our code to compile. We wrote our tests. We wrote our code in the say hello, say in the all three. We wrote all three. Okay, we got to complete the retrospective. So here, this is where you would complete the retrospective. So you complete the to do, complete experience, known issues or bugs, and sources used. In this case, probably sources used would just be this video. Then we have, go back to the README. Then we want to task 4, add, commit, push your code. Great. This is important. You've got to push your stuff to GitHub. And the link on that, in fact, let's go look at this. The link on that is right here, cloning and submitting. Okay. So if you pull that up, it links to this doc right here, and it shows you how to clone, which you already did, and then it walks you a video walkthrough on how to submit. So this is critical that you submit your code to GitHub. I cannot grade your code unless you submit it. So otherwise, it'll just be on your local machine, and that I will never see it. You can tell that this hasn't been pushed by going over here, and you can see that I have all these changes, and I have not added them. Finished app, committed them, and then synced them. Okay, so that is extremely important to do. And then well, probably even better would be to go through and let's go open up GitHub and double check. All right, once you got it pulled up on GitHub to where it was at, then you should definitely go check. And what I like to do is I like to go check something that I know I did. So I go to app and I go to source and I'll say, I'll go look at it, right? Say hello, right? So we know that we did that. So then I know that it is this, whatever is shown on this, on the GitHub in the browser is what I will see when I grade it. So that's it. I hope that helped you out, and I hope that it was fun to see all the cool stuff that we're going to do this semester. We're going to learn about interfaces. We're going to learn about all this fun stuff, and it'll be exciting. So now you should be able to have an easier time to complete all of the future assignments. So happy hacking.